Well, welcome everybody. I want to go over three specific examples of the distributive property. You don't make this mistake all the time, but too often on our tests, the mistakes occur here. You understand the relevance of the content being taught, whatever chapter it is, whether it's graphing techniques, whether it's logarithms, whether it's conic sections, you seem to grasp the content okay, but finishing the problem with the distribution property here, you're making a lot of mistakes. I want to go over example one here in blue, red, and purple. Three different types of the... Let's start with just a simple example. X times the quantity x minus 3. You don't make a lot of mistakes here, but let's give it one little shot at how to introduce how to FOIL more effectively, how to distribute across multiple terms more effectively. Let's take one term on the outside, distribute it to two terms on the inside. Looks a little something like this. I'm going to draw these little arches, these little rainbows. I'm going to draw them here so that the next couple times might lead you into a little better scenario. X times x, obviously x squared. It's not 2x, that's what I'm really trying to get at. X times x is x squared. On our test, we have too many times where either you're going too fast or you're not really concentrating. X times x, x squared. Next one. Negative 3x. That's it. A lot of you are trying to invent something farther than that. You're trying to push farther. You think there's more to it. X times the quantity x minus 3. X squared minus 3x. Moving on to our second example here. The quantity x plus 1 times the quantity x minus 5. Where did this come from? These are the factors of what polynomial? That's what this is asking. These are the factors of what quadratic? We call it FOIL. FOIL stands for first, outer, inner, last. And that's just what we're going to do. We're going to take each number on the left, we're going to distribute it to each number on the right. We're going to take the x, multiply it to the x squared. We're going to take the x again and multiply it to the negative 5, negative 5x. We're done with this term. I'm going to take out a little purple pen. We're going to take the 1, multiply by the x. Okay, 1x. Positive 1 times negative 5. Awesome. Take each number on the left, multiply it to each piece on the right. X times negative 5. 1 times x, 1 times negative 5. All of a sudden, our final solution is combining like terms. Minus 5 plus 1. This polynomial here, this quadratic, can be factored to these factors. FOIL, first, outer, inner, last. Last but not least here, we have a three-termed polynomial and a three-termed polynomial. FOIL, the acronym FOIL, doesn't really apply here. First, outer, inner, last. There's a couple of different pieces. The same steps follow. We're going to start drawing these arcs and drawing these rainbows. Let's see if we can't FOIL this together or use the distributive property to find out where this came from. Now I'm going to stop right here. I'm going to take out another color to illustrate something. X multiplied to each three pieces. Awesome. We're going to take out the red pen. I'm going to take the next term in my left quantity. We're done with the x. Move on to the y. A positive y times a positive 2x. Where might be the most appropriate place to put it? Should I put it under the x squared term? Should I put it under the xy term? Should I put it under the x term? I think y times a 2x is a positive 2xy. And if I start lining up my terms that I could combine later, it's going to save me a couple steps. Y times a negative 3y. That's negative 3y squared. I don't have a y squared yet. I'm just going to put it over here. No problem. No problem. Y times 1. I got a 1y. I don't have a y all by itself. I'm going to go over here. I'm done with my y term. I'm going to do a little erasing here so that I can show one more set of arcs. and we're going to finish this problem. All I have done so far is erased the blue arcs, just to make it a little cleaner for us. We've exhausted the x distributed to each term, we got our blue line. The y distributed to each term, we got our red line. I'm going to take out a green pen. This 2 distributes to my 2x. That's 4x. I don't think I'm going to line it up here. That's x squared. I don't think here. I think under my x term would be the most appropriate place to put that. We're going to take our 2. Negative 6y. Not under my y squared, not under this, but under my y term. Last but not least, 2 goes to the 1. That's a positive 2. There's no variable. That's a constant. Not under the x squared, not under the xy, not under this, not under that, not under that. All by itself. Last but not least, we're just going to combine like terms, write a polynomial. We're going to add straight down these columns. 2x squared, nothing. Oh, negative 3xy and a positive 2xy, that's a negative xy. 4x and 1x is 5x. Minus 3y squared and nothing. Negative 6y and 1y is negative 5y plus 2. There are various forms of this. Sometimes your book is going to have the x squared term first, and then I'll pick a new color. It could be rewritten as 2x squared. Maybe we put the minus 3y squared next. Maybe we put all of our squared terms at the front. Then maybe we throw this negative xy here. We'll put the 5x. We'll put the minus 5y and a plus 2. Maybe the book, depending upon which book you have, has them in a different order. It really doesn't matter. Something can be found here, something can be found here. Depending upon the order, you might be able to find different pieces of information. Those are 3 different examples of the distributive property. They're not all called FOIL. Hope it helped.